Hello, welcome to the calorimetry lab. What we'll need in this lab is we'll need our coffee cup calorimeters, our magnetic stir bar, our aluminum foil, our temperature probe hooked up to our LabQuest, a stir plate, a beaker, and two 100 ml graduated cylinders. We will need water. We will need 2 molar acetic acid, 2 molar hydrochloric acid, 2.2 molar sodium hydroxide, and it's hard to read, but this is our phenolphthalein acid-base indicator. This lab is going to be split into 3 separate sections. Step 1 is to determine the heat capacity of this calorimeter. We're trying to figure out how much heat will this absorb. Step 2 will be to determine how much heat will be released when we react strong acid with a strong base. And finally, step 3 will be to determine how much heat will be released reacting a weak acid with a strong base. We're going to put these 3 steps together to use Hess's law and determine how much heat will be generated by the complete dissociation of acetic acid in water. Our first thing we have to do is we have to measure out 50 mils of cold water and 50 mils of hot water. So I have a 50 ml beaker. It's probably not the best way to do it, but this will go into my calorimeter. Make sure all of it goes into there. And I'm going to put that onto my stir plate. And in a minute, I'm going to start that stirring and measure the temperature. Measure the temperature. For that, I need to get my hot water bath going and heat up my water. Too much. Now, the exact amount is not as crucial. Well, we're going to try to get as close as we can. But more important that you know the exact amount. Okay, I'm going to pour this into a beaker, put it on a hot plate, and I'm going to heat that up to 50, 60 degrees. I do not want this water to boil. If this water boils, we'll have to start this again. I do not want to lose water. In the meantime, I'm going to take a look at my currently mixing setup. So, I dip this into here. Try to determine what its current temperature is. I am now heating the water in the so to pour the two together so that the cold water and the hot water will mix. We'll get a temperature of 2. I need to get to about 55 or so degrees. I don't need too much more. While I wait for that, let's try to keep busy. This needs some greasing.
Several hours later.
Oh, shoot. Should probably go check on the water. I've taken the probe out of the hot water bath and put it into here. And I'm going to go and I'm going to quickly pour the hot water into there. Welcome to the first major error of this lab. Thankfully, I remember what to do. I thought I had a video of the temperature probe as it heated up, but it turned out I didn't. Thankfully, I remember. What I did is I was watching the temperature as it increased and waited till it reached its peak, and then it started to decrease again. And I took the maximum temperature is our equilibrium temperature. So the maximum temperature is 39. That's a 39er, 39.0 degrees. That is the final temperature of the hot water and of the cold water. So right now I'm going to start cleaning this out. I'm going to dump this water out, dry this off, and get ready for the next part. So I've got all I need to figure out the calorimetry, guys. I calculate the heat lost by the hot water and the heat gained by the cold water. I can figure out how much heat this calorimeter should have absorbed. And that's going to play a part when I consider the water we're going to use for the next couple parts. This calorimeter is going to be the same calorimeter. We're still going to use 50 mils of water. 100 mils of water each total part. So if we figure out how much energy the calorimeter of water is going to absorb, we can figure out how much heat did a reaction make. At this point, I'm going to get 50 mils of my base, 2.2 molar, and I'm going to pour it into the calorimeter and measure the temperature. Pour it in. Okay. And measure the temperature of this. I am also going to add a drop or two of indicator. which will tell me whether acid or base remains at the final step. If it is pink, it is basic. If it's clear, it is acidic. So the next step is I'm going to add 25 mils of 2 molar HCl and dilute to 50 mils, or at least the best of my ability. No, that's way too much. I'm going to go the rest of the way up with water. At this point, I'm going to pour this acid into this base, and we'll see what temperature it goes up to. One up. And we'll look to where it levels off, and then the highest temperature is where it's going to level off, and then it's going to just go down. So here's the aftermath of our acid base, for what it's worth. And I'm going to dump this out, clean it out, and start again with our acetic acid. We're going to, using the fact that we know there's 50 mils of water in each case, that add up for a total of 100, and figure out how much heat this reaction gave off, and then try to calculate somewhat how much energy this should be. And so we're going to use the same steps we did the first time. We say heat absorbed by the water, and we're going to have the heat absorbed by the calorimeter, and then we're going to use that to calculate the heat of the reaction. And we're going to take the moles of reactant and then use that to calculate our delta H for this reaction. We are going to use the limiting reagent. Hopefully, it should make sense that acid should be the limiting reagent. 2.2 molar of base, 50 mils of that. 2 molar acid diluted from 25 to 50 should be less. But maybe it's different. For this last part, we're going to test the same thing with sodium hydroxide and acetic acid this time. We're going to pour in our 50 mils of sodium hydroxide, or thereabouts. Pouring this into here, and we're going to take the temperature again. Adding the phenolphthalein as well. Now I'm going to pour 50 mils of acetic acid into the as, and then I'm going to see what temperature that goes up to. Finally, I'm going to pour this acetic acid into this base and see what temperature we achieve. No. See, that's clear again. At this point, all I have left to do is to clean up, calculate my heat of reaction for my second reaction, the same way I did with part one, only keep in mind is that the 2 molar acetic acid has not been diluted. And then finally, figure out what combination of reaction 1 and reaction 2 need to be added or subtracted together to get reaction 3, which is acetic acid dissociating in water. That's the calculation we need to do. So now you may have noticed I was a little sloppy. Maybe I made a few mistakes. Maybe there are some issues that will come up. Part of the lab is, besides that, what errors were possibly made. You can point out a legitimate error, maybe it's worth a bonus point or two. And so please attend that to your lab.